What you are seeing on the screen is a washer hanging in front of a computer simulation of a point moving around a circle. The point moves around a circle at a constant velocity. Constant angular velocity, if you prefer, and we'll talk about what that means shortly. We have a washer on a string going back and forth as a pendulum. Now what we're going to try to do is we're going to try to match the motion of the pendulum to the motion of the point on the string, in the sense that we want the pendulum to follow the line, the vertical line, the vertical projection line corresponding to motion around the circle. Now, we're not doing a very good job right now. The pendulum is going too fast. We're not going to attempt to slow down the pendulum. What we're going to do is we're going to attempt to speed up the point on the circle. Now let's see what the simulation looks like. Well, we're doing a lot better already. By speeding the point up to velocity of, you probably can't read it in the screen, but here it says 3.000, 3 radians per second, and we'll talk about what a radian is, but by speeding the point on the circle up to 3 radians per second, we get much closer to the speed of the pendulum. Now, if you've been watching, you can see that the pendulum is getting out ahead of the line again, or ahead of the point around the circle, so we're going to speed up the circle a little bit more, from 3 radians per second to 3.1 radians per second, and let's see what that does. Now if we watch this for a time, we see that the point seems to be getting to its extreme positions faster than the pendulum does. Let's watch out a little bit longer and convince ourselves that that's the case. Another thing you'll notice, of course, is the pendulum swing is getting less and less. That doesn't really hurt anything as far as matching the frequency of the motion, because the time of a pendulum's motion doesn't really decrease very much, doesn't change very much as it decreases the amplitude or the distance of its motion. In any case, we see now that the point is ahead of the pendulum, so we're going to want to slow down the simulation just slightly. So I'm going to slow down the simulation to 3.05 radians per second. Now this is going to match pretty well, and we're not going to go on with this demonstration, but you can see that by adjusting the angular velocity here, we can match the period and the motion of the pendulum. And if the pendulum wasn't decaying, in fact, the string would stay right out in front of this point if we could match the distance of this motion to the radius of the circle. Of course, we can also change the size of the circle. And we could adjust the size of the circle without adjusting the frequency of the motion to the size of the pendulum's swing. Let me just explain what a radian is. A radian is a measure of angle, like a degree, but much bigger than a degree. And I'll explain in a minute what a radian is. But in a second, 1001, this thing moves from about here to here. That's 3.05 radians. Turns out that it's a little over 6 radians around a circle. And we'll, again, deal with that idea shortly.